All right, guys, and welcome back. Hope you got your big pants on because we're learning about the radius and interval of convergence. And basically, here's what we're going to talk about today. We're going to talk about power series. And a power series is a series that has an x to the n in it. A lot of people have been complaining that these series are too straightforward because they only have one variable, just an n. They want to see, is there a way that we can put an x in and write a function as an infinite series? Wow. That sounds really fascinating to me. So something like this, like just a basic power series. So x to the n over n. So just like before, it's still an infinite series. So when you plug in n equals 1, it's like x over 1. When you plug in n equals 2, x squared over 2. Plug in n equals 3, x cubed over 3, and then so forth. Okay, so that's an example of a power series. You might also, of course, see one that's a little more complicated. So say like 2x to the n over 3n times n factorial. Now, the big question that, of course, we're trying to answer today, and that all of you have in your mind, is for what values of x will this converge? Will this power series converge? And obviously, it's going to depend on the series. And we can kind of see, right? If we look at the first case, if you plug in x equals 0, it obviously converges because every term is 0, so it adds to 0. If you plug in x equals 1, it's just the series of 1 over n, which diverges. So how can we find what values are going to make it converge and what values are going to make it diverge? Okay, so, but converging is more interesting, so that's going to be our focus. So let's look at just a few examples. And the way we're going to answer this question in general is to use the ratio test. And we're going to use the ratio test, and we want the ratio test to be less than 1, because that's when the ratio test converges, when we get an answer that's less than 1. So let's say we have a problem like this. So I'll say for what x values does the series, the sum from 1 to infinity of 3x to the nth power over n converge? And another way that you'll see this phrase is you might say, find the interval of convergence. And it's just asking the same thing. Your answers are always just going to be in terms of some kind of interval from one point to another point, and just trying to say, where does it converge? Okay, now, the basic first step on this is, like I said, is we're going to set up the ratio test, and we want it to be less than 1. Okay, so I'm going to set that ratio test up. So I'm going to set the limit as n goes to infinity of an plus 1, divided by a sub n, and we want that limit to be less than 1. So we're taking the limit n goes to infinity. You guys are good at the ratio test, so I'll just flip the fraction already. So 3x to the n plus 1 over n plus 1 times n over 3x to the n. And again, because we want this to converge, we want it to be less than 1. So just like how we always want to get in the habit of writing the limit and the absolute value at each step, we want to write the less than 1 at every step as well. Let's simplify. So like always, I'll put my leading terms together. So I'll have a 3x to the n times a 3x to the first power divided by a 3x to the n power times n over n plus 1. And again, I want that limit to be less than 1. Now, again, all the cool kids, all the good-looking kids, notice the 3x to the n simplify. So you're just taking a limit n goes to infinity of 3x times n over n plus 1. Now, when you take this limit, you're only taking the limit of the part with the n's, right? The part with the x is, there's no n in it. So when you take that limit, this again is infinity on top, infinity on bottom, so you L'Hopital. So this goes to just be 3x times 1 is less than 1. Okay, so now that I've simplified this and I took the limit at the last step, now what I'm going to get is I'm going to have to solve this inequality. Okay, so my step 2 is to solve the inequality. And I'm going to take you back to Algebra 1. Remember, if you have, like, say, 2x minus 7 is less than 3. If that's an absolute value, what that means is this part in parentheses, if its absolute value is less than 3, it has to be between -3 and +3. Right? If it were bigger than 3, the absolute value would be too big. But if it was smaller than -3, the absolute value would still be too big. So what you do is you remove the absolute value signs. You do -3 is less than 2x minus 7 is less than 3. And then whatever operations you do to all three sides of the equation. So you end up getting 4 is less than 2x is less than 10. So you know your 2 is less than x is less than 5. Just divide everybody by 2. That's what we're going to do here. So in this case, I just have the inequality 3x is less than 1. So if my absolute value is less than 1, I'm always just going to sandwich it between -1 and 1. So that's what that's going to look like. And then I'll divide like this, and then that's going to give me the basics of my interval. Now, this problem hasn't been long enough already, so we need to add a third step. So we used the ratio test, saw where it's less than 1, and we found this interval. But the issue is at these endpoints, at this x equals 1/3 and -1/3, it's equal to 1, and the ratio test was inconclusive. So the third step that we have to do is plug in the endpoints all the way back to the original series. And then you're going to ask yourself, does that series converge or diverge? Does that series converge or diverge in each case? And when you plug that in, you're going to need to use the other test that we've been using all along. You might plug it in and find it's a p-series. You might plug it in and find it's a geometric. You might plug it in and find it's an alternating series. You might plug it in and have to do the limit comparison test. Who knows? Like anything could happen. But when you're doing this, you're saying, okay, now I'm going to plug in these endpoints to check for convergence. And this is something you want to be very explicit about when you're writing these up on the AP test and then on my test as well. So you're going to plug in x equals -1/3 and x equals 1/3 all the way back to the original series right here. Okay, so when I plug in 1/3, I'm going to get the series of 3 times 1/3 to the n over n. So you just get the series of 1 to the n over n, which is just 1 over n. Now, you are still considering this as a series. So this is a p-series, so we know the series diverges. We also know 1 over n is a harmonic series, which diverges. Okay, when you plug in -1/3, you get the sum of 3 times -1/3. 3 times -1/3 to the n over n. So this is the series of -1 to the n over n. So now we consider some of our other tricks. Okay, this is an alternating series, so we're just going to take a limit as n goes to infinity of 1 over n, and we get 0. So we know it alternates goes 0, the absolute value terms decrease, so we know it converges. So if it converges, what that means is we're going to change that less than sign to be a less than or equal. Because this interval right here was supposed to be an interval of where it converged. We found that it actually did converge at -1/3. So we want to include that as part of our interval. 1/3 did not diverge, did not converge. We'll leave it like that. So this is our final answer right here, now that I've checked both endpoints. So what that's saying is that if you go back to the original equation and you pick any number between -1/3 and 1/3, including -1/3, not including 1/3 on the right side, any number back in the original equation will make the series converge. Anything outside that will make the series diverge. So again, it's saying what are the values of x that makes it converge. So that's how the problems work. I know there are long ones, but that's kind of the step. So we set up the ratio test. You're going to get faster at this as you go. You want it to be less than 1. You take your limit and whatever. And then you just solve the inequality. That's algebra 1. Just got to brush up on that a little bit. And then we just have to take the work of plugging in our endpoints and checking those. I know these problems are long, so obviously your homework will not have too many of them. Let's go to the next problem. We're going to do something similar. I'm going to say find the radius. We'll talk about radius in a minute. And the interval of convergence of the series 4 times x minus 3 to the n divided by 2 to the nth power. Okay. Now, if you want to pause the video and try this on your own, that's not a bad idea. But I will continue. So, again, we're going to do the ratio test. We're going to solve the inequality. And then the last thing we're going to do is we're going to check the endpoints. And when we check the endpoints, we're going to go back to the original equation and plug those in and see what happens. Okay, so when I set up the ratio test, I'm going to take a limit as n goes to infinity of. Okay, so that's 4, it's a constant, times x minus 3 to the n plus 1 over 2 to the n plus 1 times, and then I'll flip the fraction, so 2 to the n over 4 to the n, oh no, just 4, my bad, times x minus 3 to the nth power, and that's less than 1. Okay, the 4's cancel. And of course, we've seen this trick with the exponents a bunch of times, right? This is 2 to the n times 2 to the 1, so we just cancel off the 2 to the n's. We can cancel off, n of these. So this just ends up being the limit n goes to infinity of x minus 3 divided by 2. We still have this 2 right here. And that sucker is less than 1. Everything else canceled, right? Because this is x minus 3 to the n times x minus 3 to the 1. So that can cancel out with that. Anyway, so we have this limit. Now this limit is kind of a bust, right? Because when you look at this, there's no n, so taking a limit is like no work at all. So you still have your answer in terms of x. You have x minus 3 over 2 is less than 1. Now let's solve this. So I'm going to get negative 1 is less than x minus 3 over 2 is less than 1. So I'll multiply everything by 2. So negative 2 is less than x minus 3 is less than 2. Now I'll add the 3 to everybody. So I'm going to get 1 is less than x is less than 5. Okay, so let's go ahead now, and my last step here, this is going to be my interval, it's going to mostly look like. Now let's check the endpoints. And again, we want to be very specific and very explicit in how we plug these in. So when I plug these in, I'm going back to my original equation right here. When I plug in the 5, I have the sum of 4 times 2 to the n over 2 to the n. Well, this is the sum of 4 times 1 to the n. 2 over 2 is 1. I mean, you can just see right away this isn't going to 0. You can also say this is a geometric. My r is greater than or equal to 1, so that means that it diverges. And same thing when you plug in 1. When you plug that in, you get the sum of 4 times negative 2 to the n over 2 to the n. So you could write that as 4 times negative 1 to the n. You could say this is geometric as well, or you could say this is an alternating series, but if you take the limit, the limit is n goes to infinity of 4, that limit is obviously not 0. So that tells you that it is going to diverge as well. So if both of those diverge, that's telling you that this is our interval. Neither of the endpoints count. Okay, so this is my interval. The problem also talked about the radius, and I wanted to talk about the radius of this and what that means. Okay, let's pick, So the radius of convergence, this is my interval of convergence. The radius is the distance from the center of the interval to the endpoints. The center of the interval to the endpoints. And the way we can find the center of this interval is by saying, what do we have raised to the nth power? So if you have x minus 3 to the nth power, I'm going to set that to equal 0. So that means x minus 3 is equal to 0. So that means x equals 3 is the center. So you ask yourself, how far is it from 3 to the endpoints 1 and 5? It doesn't matter whether those are less or equal at that point. You just say, how far is it from 3 to 1? How far is it from 3 to 5? And you can hopefully see that that radius there of convergence equals 2. It's just saying 3 is in the center of our interval, and we have to travel a distance of 2 units to get to either endpoint. So this is the interval over here, and this is the radius of convergence right there. It's not too hard. It's just the difference in the center to the endpoints. We actually don't even need to check the endpoints. Like, we can find the radius before even getting to that point. Okay, so that's interval and radius of convergence. Let me give you a couple other notes here. So just a couple other notes. If we have the series for some a sub n, if we have a sub n times x plus 2 to the n, like we just kind of mentioned, the center is where x plus 2 equals 0, so the center is x equals negative 2. So if someone tells you, if my radius is equal to 1, then you go 1 in both directions, right? So you go from negative 3 to negative 1 for my interval, and then check the endpoints. If that radius is equal to 5, then you go 5 to the right, so that'd be at 3. And then on left, you go 5 left, so that'd be negative 7. So negative 7 to 3 would be kind of the basis for our interval before we check the endpoints. And then obviously, if you have, a sub n times x to the n, the center of this would be when x to the n equals 0, so when x equals 0. So like thinking back to our first example here, this was centered at x equals 0. And then the difference from 0 to a third, that distance, that radius there, is just 1/3. The radius is never too difficult at all. It's just how far are you from the center to those endpoints. Okay, so that's what's going on there with just the radius there. And I want to point out, it's always symmetric, right? You're always going 5 in both directions. Now, the endpoints may be different. We saw that, right? One of them might converge, one might diverge. They both might converge, they both might diverge. But that doesn't affect the radius. The radius is the same no matter what the endpoints do. Okay, so just some other notes. If I say that the center of some series is x equals 4, and I tell you that it converges at x equals 5, what that means is, okay, you look at the distance, right? So the distance from 4 to 5 is 1. That means that we know the radius of convergence must be greater than or equal to 1. It might equal 1 if 5 is an endpoint. But the radius must be at least 1 because it converges at a point 1 unit away from the center. And then on the other side of the coin, if I tell you that the center is 4, again, but it diverges at 3, x equals 3, that means, those distances of course are still 1 apart, that means that my radius of convergence must be less than or equal to 1. Now again, it might be 1 if 3 is an endpoint and we diverge. We don't know, remember, it could converge, it could diverge at the endpoints, but it's saying if it diverges the point that's 1 away, you can't have a radius of 3. That doesn't make sense. You can't have a radius of 10. That doesn't make sense. You got to have a radius of 1 or less. So those are just a couple notes. One more final note is that negative 1 to the n times negative 1 to the n cancel if they're multiplied. And you can kind of see this, right? Because we know if you have like 2 to the n times x to the n, that's 2x to the n. Well, if you have negative 1 to the n times negative 1 to the n, that's negative 1 times negative 1 to the n, which is just 1 to the n. Okay, cool. So those cancel out, and that's, of course, just 1. So if you see two alternating terms like that, they cancel. So let me give you just one final example here. Suppose I tell you that we have the series of negative 1 to the n times x minus 4 to the n over root n times 3 to the n. And I tell you that this series has a radius of 3. And then I ask you to find the interval of convergence. Now, if they give you this problem and they tell you it has a radius of 3, this is a big shortcut right here if they tell you the radius of 3. Because that tells us that the center of this, when x minus 4 equals 0, that tells you x equals 4. If the radius is equal to 3, that tells me that my interval is going to be going from, okay, so 3 to the left is 1, 3 to the right is 7. So we're going to be going from 1 to 7. So there's no need to ratio test. All I need to do is just kind of plug in the endpoints. So if you're given the radius and you're given the center, that's a nice shortcut. All I can do now is just check the like you can do the ratio test, but it won't show you anything you can't know by finding the radius. The ratio test kind of helps you find the radius. So now that we know it's 1 and 7, now let's just plug in 1 and 7 into this series. So now I plug in x equals 1 and x equals 7. So again, I always go back to the original series and plug that in. So when I plug in 1, I have negative 1 to the n times 1 minus 4 is negative 3 to the n over rad n times 3 to the n. I can combine all these terms. So this is like a 3 to the n over rad n times a 3 to the n. So that just becomes a 1 over rad n. Those cancel. So at this point, you're like, oh, this is a p series. My p is 1/2, so I know it diverges. So I'm going to leave it like a 1. When x equals 7, again, when I plug in 7 back into this, I'm going to have negative 1 to the n times, let's see, 7 minus 4, so that's a 3 to the n, over a rad n times a 3 to the n. The cool kids recognize these cancel. So this is an alternating series. And remember, you need to use any of those other tests. It's not just take a limit or plug in. You need to use one of our series tests, whether that's p-series, geometric, alternating, whatever. So if we take this limit, we get 1 over infinity, which is 0. So it alternates, goes 0, it converges. So we know it converges at 7. And that's how we can get the interval. So notice how much faster it is if we already know what the radius is, because we can just jump straight to the endpoints, going 3 in each direction, being 1 and 7, and then just check those two. Whew, okay, that's the basics of interval convergence. I know this is a long video with a lot of math, but I hope this was helpful, and it should serve as a great reference for you as you do this stuff. Bring me questions, class, and thanks so much for watching.